Hello everyone, welcome to this video. In this video, we shall start with the topic of arithmetic progression. So in order to understand this arithmetic progression, actually you have studied all of this in class 9th already, but still in order to recall what is an arithmetic progression, let us first have a look at this example. So in this example, suppose your father decided to give you pocket money every month. So he decided that he start with by giving you rupees 1000 in the very first month, and thereafter from the second month he would give you rupees 10 extra on this 1000. For the third month he would give you 20 rupees extra on this rupees 1000, and for the next month he would give you rupees 30 extra on this 1000. So basically each month he is increasing your money by rupees 10, right? So you are happy with this deal. Okay, so what is the sequence which suggests the amount of pocket money you receive? So I have listed down. In the first month you will get rupees 1000. In the second month you will get rupees 1010. In the third month you will get rupees 1020. In the fourth month you will get rupees 1030. In the fifth month you will get rupees 1040, and you keep on receiving the money with rupees 10 added to it each month. Correct? So this forms a sequence. Now let's have another look at another example. Here, suppose there are 10 children which reside in a building, right, in the same building. Suppose their ages, they are 15 years, 14 years, 12 years, 11 years, 9 years, 8 years, 7 years, 6 years, 5 years and 4 years, right? So they are of different ages. Now, suppose if I visit that building and I have a box of toffees with me. Now, I wanted to distribute the toffees, and I thought that I will give the maximum amount of toffee to the child whose age is the least, right? So to the child whose age is 4, let us suppose that I have distributed 20 toffees to that fellow, right? And to the child which is having 5 years age, suppose I have distributed 18 toffees, and to 6 year age I have distributed 16, to 7 year 14 toffees, to 8 year 12 toffees, to 9 year 10 toffees, to 11 years 8 toffees, to 12 years 6 toffees, to 14 years 4 toffees, and to 15 years 2 toffees respectively, right? So this table here suggests that to the children of different ages which are mentioned in this first row, I have distributed these many toffees. Correct? Okay. So that means here the number of toffees, they form a sequence, right? And this is the sequence which is 20, 18, 16, 14, 12, 10, 8, 6, 4 and 2. Now you see that this is a finite sequence that you already know. The above one, it was infinite sequence because you would be getting pocket money year after year until you start earning by yourself. Correct? Okay. So having seeing all of both of these sequences, do you notice a thing? Here, if you have noticed that each sequence we have the difference of any two terms, any two in fact consecutive terms, the terms which are lying either back to back, right? So their difference is constant in each case. How? You can very clearly see that in the first example for this particular sequence, right, we can have the difference of first two terms, which is 10, the difference of second and third term, which is again 10, the difference of second and this third and fourth term, that is again 10. So you see, if you take the difference of any two consecutive terms, the terms which are lying together, right, in this sequence, so that comes out to be constant. Similarly, in the second example of number of toffees, right, this was our sequence. For this sequence, if you see the difference of first and second term, you would see that we have -2 as the difference. Then the difference of second and third term, that is again minus 2. Then the difference of this third and fourth term, that is again minus 2. And you see, for each consecutive term we have the difference as minus 2. So the sequences in which we have constant difference between the successive or the consecutive terms, that are known as arithmetic sequences, or we have another name which suggests that we call them as arithmetic progressions, and in short we call them to be AP. So AP is a very popular acronym which is used in order to represent these arithmetic progressions. Okay, so mathematically, if we know the first term is A1, the second term is A2, the third term is A3, the fourth term is A4, and so on, the nth term or the general term is AN, and so on. So this forms an arithmetic sequence or arithmetic progression if and only if the difference of the first two terms is D, the difference of second and third term is D, the difference of third and fourth term is also D, so the difference of each consecutive term is D. So here we are saying the difference of AN plus 1 minus AN is also D, and right, if that is the case, then we will call that to be arithmetic progression. So A1 is obviously the first term, and small d represents the common difference. And moreover, you can write the general or the standard form of certain arithmetic progression AP as if you take the first term to be small a, then the next term would be obtained when you add d to it, right? So that when you take the difference, the second term minus the third term, you see a and a cancels out with each other, which is equal to d, the common difference. Similarly, the difference between the third term and the second term, it would be d plus 2d, a plus 2d minus a plus d. So this a and a cancels with each other, so you are left with 2d minus d, which is d, right? So you see, in each case we have d as the difference among the consecutive terms, and hence we have an arithmetic progression. So this is the standard form where we have the first term as a, the next term would be obtained by adding d to it, the third term would be obtained by adding d to the previous term, and so on. Correct? So this is the nth term, this is the fourth term. We keep on doing like this, we have our standard form. So I hope you understood this concept of arithmetic progressions. Well, that is it for this video. Thank you for watching.